Hello everyone, welcome to Ask Geology. This is a whole new way to understand our Mother Earth, and in this 7-minute numerical class we will be discussing about one numerical on mineralogy. So the question is asked that a mineral of uniform composition is cut into a wedge shape. The wire fringes of the wedge section is 0.012. So we can write down the wire fringes value. Okay, wire fringes value is given to 0.012. You can see this is unitless. Okay, so basically what is actually birefringes? Birefringes is simply the difference between the refractive index of E ray and O ray. This is your birefringes value, and we know that refractive index is also unitless, and the difference between the two refractive indices, that is also unitless, so the birefringes has no unit. And the thickness D, or the thickness of the mineral grain D, is given to your 40 micrometer. Okay, and now it is asking about the retardation. Okay, retardation denoted by this delta symbol. So for retardation we do have a formula, that is your thickness into birefringes value. Okay, thickness into birefringes value. So let us, before just solving this one, just know what is actually a retardation. If this is a mineral grain, let it to be an anisotropic. If this is an anisotropic mineral grain, okay, now the incident plane polarized light, what actually happens, it splits into two rays. One is E ray, one is O ray. E ray is your extraordinary ray, O ray is your ordinary ray, and they have two different plane of vibration. The two have two different vibration direction. Okay, and this O ray, this undeflected ray, is basically your O ray, and the deflected ray is your E ray. You can see this is going straight, and this blue ray, that is the E ray, it is bending to some extent. Due to this bending, it has to cover some extra path, isn't it? It has to cover some extra path inside the mineral grain. Okay, then after that, the O ray, after just moving away from the mineral grain, they just move in same velocity. But what actually happens inside the mineral grain, there is actually a time lag. Due to this bending, this E ray, it takes more time to just cover the mineral grain, and this time lag, or the difference of this time, is basically your retardation. Okay, this time lag is basically your retardation, and you can see that if the mineral grain is thin, okay, if I just say that the mineral grain is this much of thick, okay, then the bending would have taken this way, and you can see that how much extra path it has to cover. Okay, then this extra path it will cover, but the time lag will be very high. The time lag, that will increase. So this retardation value, that depends on the thickness. And another thing is that the two refractive indices of the O ray and E ray, that is your birefringes. So retardation depends upon two factors, that is your thickness and one is your birefringes. And what is birefringes? Birefringes is simply the difference between the refractive indices of the E ray and O ray. Okay, so now you can put, this is your 40 micrometer into birefringes value 0.012. so you can calculate 40 cross of 0.012 this micrometer. What is actually the answer? 40 cross of 0.012 is basically, answer is 0.48 micrometer. Okay, this is equal to 0.48 micron into 10 to the power minus of 6. Okay, this is micron. Now it is asking in nanometer, and what extra we have to multiply to make it nanometer? Okay, 10 to the power minus 3. And if we are multiplying 10 to the power minus 3, then we'll divide 10 to the power minus 3. That's why for our value, this value 0.48 micrometer value, this will not change. We'll multiply and divide the same amount. Okay, so you can see that this 10 to the power minus 6 and 10 to the power minus 9, they will cover up the nanometer. And now this 10 to the power minus 3, it will come here, 0.48 divided by 10 to the power minus 3 into 10 to the power minus 9. Okay, so if 10 to the power minus 3, if it just goes off, then what will happen? This is 480 into 10 to the power minus of 9 meter, that is equal to 480 nanometer. This is basically our answer, because the answer is asking in nanometer. So what is the answer? This is 480 nanometer. Okay, clear? And if you guys are interested to join our group, the Ask Geology group, then you can just simply call or simply text to this number, or you can mail to this given mail ID, or you can simply just click the links below in the description box. Thank you.